Welcome to Occupations, the podcast, where we discuss what it's like to hold specific jobs. Occupations is brought to you by lotsofmaps.com, where you fulfill your vintage map gifting needs. Visit lotsofmaps.com.
Hello and welcome to Occupations, the podcast, episode 23. It's Andy Jaglinzer. We're up in New Hampshire. We're at the lovely home of Marc Gagnon. And Marc is the Chief Development Officer for a company called Bixby International. They're out of Newburyport, Massachusetts. And he's going to tell us about engineering and all kinds of stuff that he got involved with. Welcome.
Yeah, thank you very much. Thank you for having me.
So, Marc, you've been working for Bixby for a long time, have you not?
Yeah, I've been there 20 years.
20 years, okay.
Yeah.
And what does Bixby create?
Bixby's a development firm, and we're what you would call a custom extruder. So we grow our business by finding opportunities that clients might have. Like, for instance, Invisalign braces, everybody knows. Mm-hmm. They need a material to do the specific things they want that material to do to straighten your teeth. So they come to us and they look for a solution. Our solution is in the form of a film or a sheet or a laminate. So we engineer laminates and then we manufacture them ourselves. So we're kind of not just a development company, development of new products, but we're also a manufacturer.
Got it. So at the end of the day, you're producing rolls of, do we call it plastic? Or
Yeah,
I mean, I know it's
yeah,
a lot of different
yeah.
possibilities there.
Yeah. So when you see a cellophane roll or you see a big sheeted product, so our product comes in the form of rolls, either monolayer or multi-layer, or it could come in the form of like a sheet of plywood, 4x8 big sheet. And for both, whether it's sheeted or roll stock, it could be mono or multi-layer, depending on what we need that polymer to do.
Got it. So they're taking it and they are punching out the shape that they need to do whatever they're going to do with the product.
Right. We're making a raw material. So we extrude. One run of our material might last a week, which, by the way, is a relatively short run for most extruders, right? But because we're doing custom products, so we'll make a long continuous roll, might take about a week to run, which, as I was saying, is a relatively short run. And then our clients will get that roll. They may be laminating that with something else. They might be putting it on a fabric to make a rain jacket. But of course, as they unroll it, that fabric and polymer coating would be punched out into some form and then made into a jacket. In the case of braces, you're cutting out the form of your teeth right up to the gum line.
That's great. And obviously, in that case, they need to also shape it after they punch it out too. So I would imagine there's a lot of engineering on your end to make it so that it can do that.
Right. So as a raw material, we go through our process, which is cast extrusion or co-extrusion. Our client would get it. They may cut a disc out of it, thermoform it over a mold to make a three-dimensional part, and then it could be cut like with a Dremel tool or with a laser, and you're cutting out individual parts, whether that, like I say, is keeping the example of braces, you'd cut out individual arches for the top and bottom of your teeth, but that could also be an automotive part or a medical device or any number of parts.
That's great. Yeah. I know Bixby's been in business for like 150 years or something
we
like
celebrated 150 years this June. It's still...
you don't even look that old, Marc.
I've been there from the beginning. Just 20 years, I said.
All right.
But the family was there. The family, it's fifth generation, wow. And they're still on the board. They're not managing operations, but very involved, which is very unusual for a company to be 5 generations family owned.
Wow, that's crazy. Yeah. All right, let's talk about you. So tell me a little bit about what Chief Development Officer at Bixby would be doing. So what is your job, first of all? Not what you do in the job, but what is your overarching
the role
picture?
As I said, Bixby grows because we're solving problems for our clients. I guess a good example might be we were approached by a designer who came and he had carpal tunnel from playing too much, racquetball. He's a very active guy, likes to mountain bike and cross-country ski. And he had hurt his wrist, and he came to us and he said, I hurt my wrist. I get this aluminum braces with Velcro and this big thing for carpal tunnel to stabilize my wrist. And he said, it's heavy. I can't do what I like to do with it. He said, could you guys work on a solution to that, a material that would allow me to make a three-dimensional brace for wrists or for broken arms that would be simpler than metal and Velcro and all of these parts.
So your job is to find that solution.
Right. So we have people approach us. We would get involved with them because if we solve the problem, we're solving it with the materials we manufacture. So we sell machine time, but we grow that conversion time on our machines by finding companies, people, opportunities where the materials aren't available readily today. So they come looking for a specialty solution or a custom solution. Prior to Bixby, I was 17 years with a big resin vendor, Dow Plastics. And we would sell polymers, they come as little pellets, into all kinds of applications, into injection molding, extrusion, thermoforming. There's all kinds of plastics processes. You heat them up and you form them into something new. So my team will meet with the engineers or the folks that are trying to create a new product and understand the environment where that product will be used, what it has to do, what functionality it needs, what the price point should be. And we see, will this work? Can we deliver a solution? If we can, of course, we'll pull those programs in. We look at, are they viable programs commercially? And is it a solution we can apply technically? If it is, we start working on that. And often we'll work together on an application where it might be new to the world. So we'll work together with them on inventing something new and ownership of something new so that when we do finally figure out the solution and start manufacturing it, we're protected because we've done something that no one else can do. And usually together with our client, often they're big clients like Invisalign or someone else, we'll have protected that space together so we can enjoy growing that business together.
That's great. So why don't we jump into your day-to-day? What's your day like? I'm sure no day is the same, but take me through, I don't know, I guess the most typical day?
Yeah. So there's definitely a rhythm. So there's 4 application development engineers, or 5. There's myself, Justin, Ethel, Tim, and Tim. We have 5 what we call application development engineers coming together every day, but we're all focused on maybe anywhere from a dozen to 25 projects that we are the project managers we're accountable to our clients for. So we're the point technically. We work with a salesperson. So a typical day would be on any one project, getting information from the sales folks, from our clients on what's going on in their development. Is it working? And let's just say a client calls and says, hey, we got the prototype you guys made for us. We thermoformed it into this. We started to build it and we find that it's too flexible. So what would happen is the engineer, the application development engineer, would take that information, go into the lab and start to analyze the issues that, as described, and start to think about, well, could we make this part from a different material? Could we reinforce this material with an additive, or should we be thicker? Is it as simple as even to the point where customers will come and go, we really love this, but we want it to be more white or red. So we're constantly, I call it iterative development. We start with a concept, and when somebody asks you, can you do this? Our inclination, we're doggedly optimistic, is of course we can. So we'll get that idea and say, well, there's many ways to do this, right? So first we determine, is the best way to do this using our process? If we think it would be better, say, injection molded into a three-dimensional part from the get-go, we'll pass that client on to folks we know in the industry who have a different process than us. But if it fits the process, we might make 3 or 4 or even half a dozen prototypes. So those are tries at the product. We know they'll never be right, but I look at it this way. When I was at a big company, you have a lot of PhDs, you have brilliant people, and you do a lot of research. Before you even make a prototype, you might be researching for months or even a year. And then if you think you have a good path forward, you have to build a team and get consensus among a lot of people, and you move forward. That's kind of organic growth. And big companies aren't great at that. So it's too small. They're not going to do try, fail in the small way that we would. But we might make, using our processes in a morning, make 5 or 6 prototypes, get them to our customer and say, go beat the crap out of these. Let's see if they fail and tell us how they fail. Tell us what you don't like. We don't really care what works. We want to know, okay, 80% worked, but this didn't. And then after getting that feedback, we'll take the parts back, or we'll take the concept and say, okay, well, in order to make this work, we need to go with a more flexible material or a more rigid material, whatever it is. And so we're tailoring the material and the construction. As I said, we're building functionality in the material to do what our client wants it to do. You can get that functionality through different polymers, through different additives in the polymer, or through different layers. So if someone asked me, oh, Mark, I want a product that stretches only in one direction, but doesn't move in the other direction, perpendicular to that, I don't want it to move at all. But you can't make that out of a singular material. So you know right away you're going to have probably some reinforcement that stretches in the X direction, but not the Y. So by using multiple layers, we can really start to control the functionality of the final part. And that's why you see us solving problems in so many different industries.
Well, and solving problems is really the name of the game, right? And I know you're up for a good challenge. How long does it take typically to go from the napkin drawing that someone hands you until you get a prototype? Ballpark. I know that varies. But
great question. Ballpark, we kind of do track this loosely. It's about 3 years just on the material side. And understand our clients have probably been working on a concept for months or years before that. But our piece where they're saying, hey, we've identified that we need this type of material. We don't really know what we need exactly. We think your company could do this. From the time we get it, start putting down those 6 first tries. It's about 3 years to get to what I would call commercial, to where we're running it at scale. Not necessarily, it's not accepted in the market, but we're starting to manufacture it.
So we got a sense of what the job is, but now how did you get there? So let's start at the beginning. Where'd you grow up?
I grew up in Chelmsford, Mass, about an hour south of here.
All right. So at what point did you think engineering was probably your path? How old were you?
Well, when I thought engineering, it was probably 16, 17. But when I thought problem solving, and from the time I was 5, I would bust things up to see what's inside. I loved if it came with batteries, because then I knew it was driving some mechanism or something. I had a little friend. Our plan was, I was going to be a carpenter to build stuff, and he was going to be an electrician, and we'd work together building houses, right? But so from 5 to 10, we were building birdhouses, tree houses, go-karts, version 2, 3, 4, 5 of go-kart stilts. We built a scuba, we took a 1-gallon jug and, rigged up a snorkel and tube to it so we could make a scuba tank, because we saw Jacques Cousteau. He was big in the 70s, right? So yeah, for me, it was always, I loved building things and innovating solutions around those. So, and I loved drawing. When I started to realize I had to work for a living other than, at 8 thinking I'm going to be a carpenter because I saw the guys in the neighborhood building houses, I thought I wanted to be an architect, because I was in an art class. I was sketching and drawing. And one of the things I said, draw a house or design a house. And I thought that was really cool, because I put like a giant aquarium in the middle of the house, and the hallways would go around the aquarium. I thought that could be like a pool you swim in with it. So I was like, wow, that's what I want to do. Until that, now this is in the 80s, right? Early 80s. I said, architecture, they said, you're going to starve there. They were career counselors. And I sat down and talked with the guy about it. And he said, you sound like an engineer. So that's when I first kind of thought engineering. So I'd say it was probably about 16, getting ready to think of where I wanted to go to school.
Great. And did you get any classes on engineering in high school? Was there such a thing?
Not per se. There was physics, of course,
physics and
math,
there
was math, and I liked that stuff. I did well at it inherently. So, and science I liked.
And where did you go after high school?
I imagined I'd go into aerospace engineering when I started to think about engineering, or some kind of mechanical engineering. I was the third. I have an older brother and older sister. We're 1 year apart. So I was the third going into school within a 3-year period. And my dad's like, the schools that had good mechanical engineering programs were private schools. I was at Worcester Polytech and Northeastern. And then there was UMass Lowell right around the corner. And my father knew a bit about it from the Lowell Sun, reading in the paper. Said, they have a great engineering program. And so I started to look into that. And that program was plastics engineering. Another thing that I love doing from the time I was 2 years old is skiing. And I had read an article in Ski Magazine about a Rossignol engineer who was skiing with a strip chart recorder. In the day, like these are, analog big devices, and they wired his skis up for vibration and everything. And I thought, that's the job I want, an engineer designing skis. So when I saw Lowell Plastics Engineering, I thought, perfect. Skis are made out of polymers, ski boots, bindings. It's like I could get into the ski industry. So I decided to go to UMass Lowell, partially because my dad said, that's where we can afford easiest. But it really was the best decision, because I did not realize, we all think as soon as you pick materials engineering, you're stuck in some sort of box that it's all going to be the same, and it's not. You go into mechanical engineering, you could work in a vast array of jobs. Same for me, going into polymers is really materials. We had to learn about all materials and see where it's the proper use, the efficient use of materials. That's what your engineering degree is understanding the mechanics and the chemistries and the physics of what your product needs to do, and putting the best material in there. It might be wood, it might be glass, it might be plastic.
Yeah. So you finished up there, or did you do any internships or anything that sort of pushed you in a different or specific direction?
Well, once I knew I was going into plastics, it was my sophomore year at Lowell. I took a job at a plastics plant. They were doing extrusion, but it was extrusion blow molding. So that's just like extruding a molten tube, and then a mold closes up over it. They blow air into it, and it makes a three-dimensional part, hollow part. There was a company called Family Products. They made coolers, so the lid to coolers, and so they were making these hollow blow molded lids, and then they had another process to make the cooler itself, the body of the cooler. But you needed two walls, and then you'd foam polymer between it for insulation. So I actually took a job there and just working on the lines and getting to see how polymers were being used in industry. So that was probably when I was 18 or 19. And good experience. I ended up driving a forklift, which I loved. I worked in the line for like a couple months, and then for most of the time I was there, the last 2-3 months, I was driving a forklift and setting up the line. So I really got to see a production operation and interact with the engineer. I was just curious. So I knew the guys that were at the back of the plant working on the engineering side.
So when did you lose your drive to have a career in forklift driving and go back into engineering?
When I realized they frowned upon racing them down the aisle. There's a whole safety thing you got to be aware of, and those are...
And what's next for you?
Well, that was my first internship. I went to, as a junior, I decided as a junior that I wanted to get my master's degree. I wanted to specialize a little bit. I wanted to get all my learning done. I had friends that had worked and, got an advanced degree while at work, and it just looked like a difficult thing to do for me. I need time to be down, and I saw how busy that gets.
Sure.
Kudos to people who do that. But so I was like, I do want to get my master's. I'm going to focus on my education. So I ended up taking an internship at Procter & Gamble, and I was out in Cincinnati for 4 months, and again, got to see different processes of plastics manufacturing. They sell all those products, but they actually, at least in 1980, probably 3 or 4, they had a whole team of engineers working on really unique technologies to package products and or diaper technology. It sounds so mundane, but
diaper technology.
There is a lot of science and a lot of materials, knowledge and engineering that goes into the most mundane of products, if they're good products. And good products are generally the simplest. They're not complicated, but you got to be really expert in your skills to make something correct and simple. And so I kind of saw that there. And then the year after that is when I went to Dow Chemical Company in Midland, Michigan, in the plastics division and engineering plastics. And that's where I really got to see, you'd see the materials being made, and the variety and the variables to make those materials unique and different. I thought that was really cool. But what I liked was taking that polymer out to a potential customer and putting it in a molding machine, putting it in an extruder or in a blow molder, and seeing what it could do and seeing where it failed, how it was, that really combined mechanical engineering with process, and it's cool processes and then materials. So I kind of realized that internship that's what I wanted to do, was be at the interface of the material design and how it applies to products.
Got it. Were you aware of Bixby at that time or no?
I really wasn't.
Okay.
Not when I graduated college, but shortly thereafter, when I was at Dow, I knew Bixby was a client. And big for me was to remain in New England, which I didn't do. My wife and I have known each other since we were young, and we knew in college that we wanted to get married. And she was working in Boston. She's a writer. I went to Midland, Michigan. I was there 3 years. She was there a year. After a couple of years, we got married. Yeah, for us, geography was a big thing. We both wanted to get back to New England to be with our family.
Sure.
So we were in Michigan for 3 years, then we went to California, and then ultimately came back to New England. And when I did, I was back with Dow. I mean, I was with Dow for 17 years. When I came to Boston, Bixby became one of my clients. That's how I got to know them.
Got it. What was your position at Dow? What kind of things were you doing for them? And what kind of products were you working on?
So Dow was great because, I just got my master's degree in plastics engineering. I knew processes really well. I knew materials, polymer materials really well. The first job I had was called Technical Service and Development. And that job was to represent all the different polymers in engineering plastics for Dow, represent those to our clients and look at where they can be used. We're trying to find applications that, one of my things was Kirby vacuums. Those vacuum cleaners are steel, and that's their brand. I didn't realize that. I went out there and said, boy, that steel is awful heavy. It costs a lot. There's a lot of inefficiencies in using it. But their brand was it'll never break down, right?
Right.
But then I talked to some other companies, and for me, looking at what is the right material, that was really compelling. So tech service and development was going out there, seeing how things are used. I'd go out when things were failing, when it wasn't processing well, when things were breaking, and troubleshoot that. And that is a great education. That's how you build your skills and your practical knowledge. But that, for me, didn't feel super creative. It's problem solving. But I started to look at, man, what's really cool is developing the material for an application so we get it right the first time, get the right material in there the first time. At this point, I'd moved to California, working out of a plant in Torrance, California, and was calling on the West Coast, and got involved in looking at materials used in irrigation systems. That was a big thing out there, small appliances and other things. But that's where I started doing application development, working with product designers at companies like Toro or Hunter Industries that make the golf sprinklers and commercial sprinklers, Rainbird. I'd go and talk with their engineers about what they're trying to do and what were the problems they were seeing as it related to material, and trying to develop blends or materials solutions for them that would allow them to make a better product simpler.
So you did that for 18 years, 17 years?
17
right?
years with Dow, yeah. And I ended up there so after application development, I moved into licensing of new technologies and business development specifically with polyurethanes. So I was working with a lot of customers around the world on applications that at that time were using polycarbonate or urethane. Then I ended up just in urethane, new business development. So I started working with what we call film and sheet, fibers, and fabric coatings. That's where I got to know Bixby, because they were one of my companies we called on that was within my purview in terms of bringing new materials, solving problems. And what I loved about Bixby, number one, they were in New England, but they had their own pilot line. To develop a product on some of this machinery, one extrusion line, it could be millions of dollars, and $3 to $5 million, and you have ancillary equipment, and it just keeps going up, right, to get it to do what you want it to do. So it's very difficult if you're doing development of a new application to run a prototype on equipment that costs millions of dollars
Sure.
that you have to run tens of thousands of pounds to make it worthwhile, right? You got to absorb your startup and your waste and everything in a run. That doesn't happen on manufacturing large scale equipment.
Right.
So Bixby had these small extruders dedicated to development. And right there, I loved working with them. I had half a dozen programs going on there, and it was one of my favorite places to visit and work with the engineers there. So I loved Dow, but I was going to have to move to Texas to continue to advance in my career. And now I have a 4-year-old and a 6-year-old. And I'm like, there's no way I'm going to Texas right now. And my wife and I are from here. So, that's where I started.
You'd have to get a horse and a gun.
I like that. That would be fun. I wanted a cowboy hat, but...
Okay. You can always buy a cowboy hat.
Yes, right.
Lotsofmaps.com. Vintage, local, national, and world maps for an affordable price. 99% of our maps are $25 or less. Great as gifts. Frame them or put them under glass for your home, vacation home, or as a memory of a special place. Lotsofmaps.com.
So, Mark, we find you at Dow Chemical, and you've got a choice to make. You're on your way to Texas or not.
Right.
And you've got your family here you got roots here in New England, and you want to stay.
Yeah.
So what happens next?
As I mentioned, when I saw Bixby and was working on programs there, what I found is it's almost like a blank slate to do development the way I had imagined it could be. And like I said, Dow was great, but it was really hard to get anything moving. And we did a lot of programs that actually never came to fruition, and you don't feel like you're making a huge impact. But you go to a smaller company. At that time, Bixby had just lost a big account that made up a large majority of its sales. And it was kind of sink or swim. I was at a stage, I think it was 40 years old. I'm like, this is cool. I've got a company that needs to do development to grow, that has tools there, and potentially, if we're successful, the ability to invest in better tools to do development better. And I had realized at that point, what I enjoyed the most was the creative side of engineering.
Sure.
I
guess being on the ground floor of products must be a fun thing too.
It really is. Like, the product idea is there, but nobody knows how it's going to get built yet. And people say, well, my son's a designer. He's designing footwear. That's wicked cool because you get to envision what it's going to look like and everything. And by the time he writes that or lays out the last design and you look at it, you're like, wow, that's a cool shoe. But that's the end for the design. And now it's like, how are we going to make this happen? And what are the materials going to be? That's like, I love how engineers are characterized. Like they have pocket protectors and real geeky. And hey, we are. I mean, I think anyone who loves what they do is geeks out on it, right?
Sure.
But to me, engineering is an extremely creative act. In the same way, and I always say this, I like to think of us at Bixby, and this is what was so compelling to me to answer the question of Bixby, is I can create what I want there and create what I think is best, and I'll have to do it efficiently, means quickly, cost effectively, fake it till you make it, utilize the tools you have so you can get better at it. But I'm like, what an opportunity to create not just the ability to create solutions, but to create an organization that can really do development well. I thought of it as I'm an artist. And honestly, I told you, I loved drawing when I was young.
Sure.
I wasn't great at drawing. I was a good drawer. I never had any teaching in drawing, but I still, to this day, when I retire, want to start painting and learn some skills.
Nice.
But that's the thing. An artist is a geeky engineer solving problems. If you think, they've had to learn colors, tones, blending those colors, what tools, whether it's a brush, your finger, or a knife that you're going to apply to the canvas, different canvases. There's a whole set of skills you have to learn to make a masterpiece. To become a master, there's a lot of very technical, boring skills. Same with the musician. You got to learn time and tempo. What's the count? That is all really dry, boring, geeky stuff until you take it. And the thing is, we can all relate to beautiful music. We can all relate to a beautiful picture. It's subjective, but we all know, wow, that's really nice. You don't notice it in regular life because the cups we're drinking out of were designed by somebody and put in the material to do a very specific purpose. It can be done well, simple and beautiful, or it can be done crappy. And, we see the discussion in society today about single-use plastics. Well, that's not a good place to use plastics.
Yeah.
Plastics have changed our world, and, we're sitting here surrounded by plastic. Every material has a very specific purpose and an efficient use. And when we as humans don't do the hard work to get the best, the efficient, the simple solution, well, we're going to pay. And so I look at an engineer as a very creative person. You've learned your skills and you're an artist. You're creating a whole new product that wouldn't have been there a year ago. And hopefully it's the right material, the right use, and it allows the product to really shine. I mentioned early on about, a designer who had this carpal tunnel and he had metal bent and Velcro.
Right.
Well, what we ended up with was like a tenth of the weight, exos bracing. I'm sure a lot of people have used them, or kids who, broke their arm playing soccer. You get an exos brace. It's a polymer that's quite stiff, and strong polymers, to make them move, you need a lot of energy, right? The stronger something is, the more energy you need to deform it. Well, that's true. One type of energy is temperature. And so they said, Mark, we want a really strong cast, but we want to be able to heat it up and form it like clay on the patient's body. I'm like, you're crazy, man. Physics don't allow that, right? But with proper engineering, like we said, artists might blend colors. And look, we said, hey, we can blend some materials together. We can use different materials, additives in a way to make a very stiff, strong polymer that, oh, look, at the end of the day, we could heat it to 170 degrees and form it on a broken arm and cast that arm. The next product, it's a continuum, right? So now that you have that knowledge, those skills to make a relatively stiff polymer form at a low temperature, they said, Mark, let's make a prosthetic socket for, soldiers who've lost their legs. Or how do we make a socket to fit a limb simpler, better, cleaner? And today, the way it's been done since World War I is you make a cast and you put plaster on and you form they call it a check socket from a cheap polymer. They pull it over that cast. They put it on the patient. They say, walk around for a while. Tell us how it feels, like trying on a pair of shoes, but you got to walk around for a couple of weeks and you got to leave the prosthetist and you got to go home and you come back 2 to 4 weeks later with sores and calluses and bloodied areas where it's like, this is really not comfortable. So, well, you got to do this because now we're going to take that mold and we're going to shave it and build it up and we'll pull another check socket over it and put it on the patient. Well, this process can take a month to 2 or 3, back and forth, long, painful, because ultimately they're casting it from fiberglass or carbon fiber. That's the kind of strength you need to do this. So the same designer was talking about carpal tunnel, said, could we do a prosthetic socket in that way? And I said, it's crazy. No, because you need 1 million modulus, right? Like it's 4 or 5 times stronger than what we did for the cast. And the stronger the polymer, the more energy you're going to need to deform it, right? So we're going to have to heat the crap out of it. It'll burn a patient. They'll be scarred for life. No, can't do it. Then we started to work at it. And we realized, well, a patient wears a silicone liner under the socket, and that protects you from heat when they're forming it. And lo and behold, we got a 1.3 million modulus socket that the prosthetist could put on in the morning in the office, and the patient walks away. And you get a perfect fit because with heat, you can form it right on the limb. And then they come back. Maybe they had a little water weight the day they went in, or they had, Chinese food, MSG. They were all swollen. So now all of a sudden they come back and they say, geez, this doesn't feel quite right. The prosthetist just takes out a heat gun and can reform it. You don't have to go make a new socket.
Wow.
That's a huge process. So yeah, that kind of thing to me, that's what's fun. That's where you start to realize, wow, we've mastered this materials thing and it takes great engineering skills, but I'm not out there doing formulas every day. Right? You build up a body of knowledge and understanding, and you can always go back to those formulas and the stuff that people think engineering, that the pocket protector geek has to know.
Right.
But now those things become a little more in your gut, and you're making creative development. You're being innovative with your body of knowledge. And that, to me, that's what was really cool. Leaving Dow, getting a bit of a foundation, and starting to look at how do I grow a company? How do we How do we get a flywheel spinning that says people are going to come to us with their problems so we can solve them in manufacture? And to be a manufacturer in Massachusetts, in Newburyport, Massachusetts, is no small feat. By nature, taxes are aggressive there. Regulation is more aggressive than it would be, say, in other states or really in South America or Asia, right? So we need to make sure we're solving problems well, quickly, and problems that bring value to justify what we're going to have to charge for a solution that we're going to manufacture in Newburyport, Massachusetts. So that whole thing, even developing the business, is an innovative, creative process, that our team is engaged in.
So was Bixby doing this prior to your arrival?
So they started to get into some engineering applications there, because there were, solutions in automotive. If I think back, boogie boards, this is going into the into the 90s, those were made by Bixby.
Huh.
And fast forward from, say, 90 to 2010, that industry went away because you started buying them from China. They were made from propylene and foam and really cheap. But in the day, they were like a surfboard. They were customized, and they had what we call it ionomer Surlyn. It's on the core of a golf ball. But so Bixby was doing that in the 80s, 90s, early 2000s. But the big thing that carried them was cured in place pipe. It was a coated felt that could be inverted into a drain pipe, drain waste out on a city street. So rather than digging up a cement pipe or plastic pipe or brick, or in Boston, wooden pipes, you can just blow in a felt with a polymer lining. Felt is 80% air. It would carry a 2-component curing thermoset. And once it got in place, you'd put some hot water in there or steam. It would cure a rigid pipe inside the wood. So now you don't have to dig up the city street and shut down business, roads, and the retail. And
wow.
So, you're shutting down restaurants. And so it was a big deal. So that's called cured in place pipe. And we were making a product for one of the biggest players that started that industry. So that carried Bixby until 2004. I started in June. September, we took the last order for cured in place pipe. So they said, Mark, we'd love to have you because we're about to lose big piece of our business.
Yep.
We need to start looking at where else can we take our ability to make multiple layers or mono layers of polymers and other fabrics or reinforcements. We can use glass, we've used steel, but for the most part, it's different polymers and films with either felts, foams, different layers that come off of rolls, and we can extrude and coat rolls and start to laminate things together. We can end up with 7 different discrete layers of different materials to make one sheet that might be formed into a very sophisticated product.
That's amazing. And so they bring you in, and what are they charging you with? I mean, obviously they want to develop new business, but are you offering a new service because you're in there in some sense? I mean, what is it that you're changing about their business?
Right. Well, they had a guy doing what I was doing before I came there, and he had left 6 months prior to my arriving. And, you hope you're bringing something new, right? But really, my predecessor, John, great guy, he was looking for opportunities in the marketplace that Bixby could manufacture film, sheet, or laminates for. Having been at Dow for 17 years and traveled to extruders all over the world, Europe, Asia, throughout the States, also injection molding, you have a pretty good idea of the industry that you're going to be playing in and what your place is in that. So what I brought was a knowledge of the industry, a knowledge of the materials being used, and an understanding of the processes that Bixby had. But there was one thing very unique about Bixby, and it was that most manufacturers are purpose-built to make, let's say we were talking about, say, Invisalign. They're making braces. They're making the software to move your teeth, and they manufacture thermoform from our material of braces that will actually mechanically move your teeth that you're going to snap in your mouth, right? That's all they do. Bixby wasn't purpose-built to be a dental company or to be an automotive company.
Right.
Bixby was purpose-built to be quite adaptable and flexible, because when I got there, they were already making endless belts that like they're replacing rubber, which is it's a type of polymer, it's a thermoset. We do thermoplastics, but we start replacing belts for mining or for managing inventory in a warehouse that ships product, or you see at the airport the belts carrying packages around and stuff. They're everywhere. They're ubiquitous in food processing.
Sure.
They carry the various ingredients. So Bixby was supplying those in a big way. They did the cured in place pipe. So my predecessor was looking at new applications. When I got there, people were really starting to look at solar industry. So we had opportunities to make laminates for solar panels. You have the glass front, but everything else in there is metal conductors and polymers to be a package that'll last for 25 years. We started looking at places where, what could we do with multiple layers, with adhesives? What markets does it take us to? And so I came there with an environment that I knew and players that I knew, the resin suppliers, the polymer material vendors, the compounders of those materials, the people who make the additives and processors, and said, okay, there's some missing gaps here where Bixby, with its skill set to be quite flexible, with its ability to be innovative because of the flexibility of its processes, and having smart materials people, let's fill this niche that is left by the big resin vendors of organic development, of solving problems. Like what happens with us is we'll solve a problem, we'll grow it to tens of millions, maybe dozens of millions of dollars, and then some big company comes in and says, let's buy that technology, right?
Right.
But it had to start somewhere and grow and have that investment when it was small, when it wasn't attractive to a lot of companies. That's where we play. We take it when it's a nice little nugget, grow it, and then hopefully protect our intellectual property, our IP, via patents or trade secret or however else, through good customer agreements, commercial agreements, grow it, and then have somebody acquire that and take it. So they were looking for development.
Got it.
They were looking for someone who understood materials, process, the market. And of course, I've got a great team. There was a guy that I worked with at Dow for 20 some odd years. He came as our sales and marketing, and our president is from DuPont, just very knowledgeable in that environment as well. Our operations guy has run more and bigger plants, and he really understands efficiency, lean manufacturing, and great team.
So you actually form partnerships with your clients. So you're a part owner of the materials that you're making as well?
So there's a bunch of ways we go to market. And I would say the first thing is don't be greedy. Everyone's bringing something to the table. But what we've realized in solving a lot of problems is these things won't happen. No one's going to buy pound one if you don't have a good solution, right? Or if you've put it in the wrong material and it's not working as desired. And if you don't have a process to make it. So Bixby will develop that material, the combination, the processes to scale it up. So I mentioned to you, most companies aren't going to do that. They can't do development on a production piece of equipment.
Right.
So we have this neat environment where we can take the idea and pull it up to right before you're going to scale it. So what we do is we say, listen, we're willing to do that with you, customer A, as long as you're willing to agree that we're going to be the manufacturer of this solution as long as we can. If we can't be cost competitive, or if we can't scale with you, well, we're happy to license it and let a big person in South America manufacture it, and we're just going to get a little trickle off of that we call royalties, right? So that is one way. The other way is, people say, hey, listen, we've been engaged with multiple startup companies. I mentioned Exos. There's the other one, the prosthetic socket is Extremity. And these companies were bought by multinational, multi-billion-dollar companies. Exos is owned by Enovis. Prior to that, they were Don Joy Orthopedics. And we've made mistakes. Like we've set our technology off on a train and said bye while the train successfully grew and went into over the horizon. And we're going, what the hell happened there? So that's where our commercial guys and our president and our CFO, where we're being smarter about, okay, we have to have good agreements with our clients or we won't do it. Right. And the thing that people don't appreciate, or our clients can't appreciate, is, we're doing it because we want to manufacture, but we're unique. Go to any other company, they're not going to do it because they don't have the scale, the small scale, to do it well. So you go to universities. Universities are great, but they're glacial in the way they move. Because they're not for-profit organization racing to move a technology forward. They get it, a student will work on it. So we're just a really good balance of, having production scale, lab capability, pilot scale, and then lab scale for processes. And then very knowledgeable people who know processes, materials, and product design.
I've seen these rooms. I've been in there, and I've watched you play with a lot of really fun things. That you have a mini extruder, which is nice, so you can do things at a really small scale for testing. And then you've got a whole testing room where you can rip things apart and blow them up and whatever it is that you do.
Part, destructive testing.
It sounds like that's not something most companies would invest in.
It's that, and then there's analytical testing to where you get into some of the characterizing different materials and understanding where they soften and where they get rigid and where they're rubbery, and all of that's really critical, and it's rare that you have all of it under one roof, right? Why am I proud of Bixby? It's because it's a company, and I like to say, everyone, you're always the center of your world, right? But we're kind of the center of a hub, and the spokes go off to resin suppliers, additive suppliers, compounders, folks that would be maybe slitting and winding or surface treating our material. So we have all these relationships, and we can say, listen, don't worry. A university won't have all those relationships. A purpose-built manufacturer, extruder, even if they have the same processes, they're making yogurt cups, right? And that's their business. They might have a dozen types of yogurt cups. Their development is within yogurt cups. So they're not going to go make a medical package that, can answer some unique or work in unique environments and solve some unique problems for the client. So that's where our secret sauce is.
Yeah, and obviously having those relationships with other materials vendors and such. I mean, you're not basically saying, well, we'll do the plastic thing, but you got to come up with the rest of it on your own.
Right.
I mean, this is good that you have that capability of being able to do that.
That's really intuitive because we are material agnostic. We're buying from Europe, from the States, from Asia, materials and other additives and services. So when I was at Dow, imagine I had multiple shades of blue when I was selling Dow's urethane. I mean, they have other polymers, right? But if I know it's got to be an elastomer, you have a finite number of materials that you can use. And so our vendors will actually help us store our shelves with a range of their products. They'll give us the spectrum of urethanes and a spectrum of block copolymers or whatever it is, right? And now I can pull it off the shelf, and in the morning I can mix it up. We have compounders, small compounders that are like big blenders that blend it and make little pellets for us. So I can mix a bunch of things together, put it in our extruder, extrude it, thermoform it, test it, and say, is this doing what I want it to do? So, and we can do that in one day.
Fun.
Yeah, it's all under one roof, where that's pretty unique, especially when you have license to do it in any industry with any material.
Right.
If you're at other companies, like I say, they're purpose built. You can do it for yogurt cups, but there's a small number of materials that are going to be used there that are cost effective and do what you want it to do. So it's really fun and creative because of that flexibility.
So if I wanted to eat yogurt on the moon, I would need a different type of yogurt cup, but you could figure out what yogurt cup would make that work.
Exactly. Well, we'd put a straw in it so you don't have to try and scoop it out, right? Yeah.
All right. Well, this was not supposed to be a commercial for Bixby, although they are a wonderful company, and we're going to talk about you.
Right.
I'm going to say you like your job.
I really do. Yeah. I like creating. Right. And I told you, when I was a kid, I tore things apart. I want to see how they work. I want to try and put them back together so they work. Or can I put it back together differently? Can I put it back together better? Can I take this part and make a go-kart with a little motor from a lawnmower or whatever it is, And so that's what I do every day. I'm getting paid to understand materials from all around the world, processes, and you can't understate that because there's a process for everything. But with when you're melting pellets and forming them, like everybody knows Play-Doh and how cool that was. So we're doing that every day, and then looking at, after we form that sheet, how do we form it into something else? So really understanding from the beginning to the end, there's a bunch of processes that occur that are each one is a unique solution in its own right. Some have been around for decades, and every year equipment manufacturers are coming out with different things, or you'll read a patent about how someone's doing something. And to me, there's so many variables that you pull together to solve problems, and that is the ultimate in creation. That's what I love. I think every job has to be creative. Again, I go back to that engineer with a pocket protector. That's a really bad stereotype for me because, I see a guitar player, I see a painter, and I see a good engineer, and I'm saying they are all unbelievably creative people. They've had to spend their 10,000 plus hours somewhere developing their skills, cut them loose.
Experimenting yeah.
So my job is finding those people and letting them go play and grow to be a master artist in that area of process, polymers, product development.
Now, let me ask you this. You've got a family. How do you turn your brain off?
My family would say I don't. On topics I understand, it's like drinking from a fire hose, but I know I'm a high energy person. As you go through your life, and I look at this in my journey from, when I was trying to make a scuba tank from a 1-gallon jug
Sure.
to today, for me, curiosity drove me to do things that I thought were interesting right through college, and I continue to move toward things that I find interesting. So if someone said, do you want to run the company? Hell no, of course I don't. Or do you want to run the operations? No way. Do you want to run sales? No. And you got to be true to yourself. Sometimes you say, I think that'd be cool. It's different. But it wouldn't be me. And I know that. And it takes time to learn that as you go through your career, right? To make each little decision, which is really setting your direction. And a lot of times you make the wrong decision and it puts you in the wrong direction. So you course correct. You say, I really don't like this part of it. Like there's a lot of analytical stuff that I didn't like that got me more toward the pocket protecting type of engineer, right? A single task all day, my head's going to explode. So, but I've seen others that just love going deep. So I know that's not me. So I course correct and I end up here. And that's why, you talk about my family. I tell my kids, got to have a skill, get your skills, go to school for understanding a skill that you can apply that has value to society. I don't care what it is. If you like it, you'll be good at it. And if you don't like it, you'll course correct and you'll end up where you want to be. And I see that, I got a 24 and 26-year-old and I see that in the decisions they make every day.
Sure.
And they're doing cool stuff.
So what are the odds that you're going to wake up from a deep sleep tonight and say, I know exactly how I'm going to get that yogurt cup on the moon? Is there good odds that that's going to happen?
Very good odds, yeah. Happens all the time.
All right. Excellent.
Yeah.
All right, Marc. We need to discuss some advice that you might have for folks that are interested in maybe becoming an engineer. Obviously, there's a million types of paths you can take to become an engineer. You obviously took it to plastics. But let's talk about suggestions of where to start or advice of what to do at some point during this process?
Well, if you're in high school or middle school and you have mechanical interest, technical skills, you love building things, you love solving problems, especially mechanically related, you have curiosity about the stuff of the world, the products in the world, I'd say you've already demonstrated an inclination toward understanding how things work and what things are made of around you. And that really is engineering. Engineering it's a word that says we're going to look at something and try and find a solution to a problem. We're going to innovate. So, I would say this, if you're middle school, high school, there's probably someone in your family that's an engineer or a technician in your neighborhood, at your church, or wherever you hang out. Find out someone whose dad is an engineer or an uncle who's an engineer and ask them if you can go, visit them on a Friday afternoon, get a tour of what's going on, ask them what they do. You're right. There's so many disciplines within engineering, whether it's mechanical, aerospace, materials like what I'm doing in chemical engineering, electrical engineering. So high level, I would Google those different types and see if any resonate with you, but then ask around and go to work with an engineer. There's many guys at Bixby who've come out and done a tour. One of the rock stars on my team came out when he was in high school, and we did a tour, and he said, geez, I really like that. It's cool. And he's just killing it right now. He's been working for us almost 5 years and just gets it. So yeah, find an engineer, get exposure, see if you can get a tour at a plant or at a manufacturer, and find ways to expose yourself to that. And obviously, there's a bunch of books on engineering. If you think you know, like, oh, I want to be a mechanical engineer, Google that. Get a book on it. I'm reading a book right now just on the creative. And I would say, if you're a creative person, you're going to like engineering. Don't just hold yourself to what I call the analytical and the math and the science technology stuff. Those are the core skills you need. But if you're going to use those skills in a fun way, in a creative way, in an innovative, in an effective way, you need to know them well. They become part of your gut, and you can be creative with them then. That would be my advice.
Would you also advise people to destroy things at their house, take them apart and see how they work? Obviously, you started with that. I know things are a little different now with chips and all that other stuff, but
I'm adamantly nodding here for yes. Like, honestly, the curiosity, breaking into something, what's inside that, if that's where you're geared, if you get excited when your Christmas present has batteries, taped to the box, you really should start to explore engineering.
So what about folks that are already in college looking for some advice of maybe they've just discovered engineering, or they're coming to a point in their education where they need to start making some decisions? Mm-hmm. Are there any suggestions you might have for those folks?
Yeah. It's the really rare bird that knows when they're in college exactly what they want to do. And, I knew I wanted to go into engineering, but I mentioned mechanical aerospace, and I ended up in plastics. So I was interested in the ski industry when I was in my teens, right? I could have applied any of those to the ski industry. In the same way, you get your basic skills of engineering, but the most important thing for me is look for an opportunity to apply it. So there's unpaid internships. There's a lot of paid internships in engineering. And even if all I'm going to be doing is filing for a bunch of engineers that are doing the cool stuff, you're going to see, you're going to learn, you're going to be exposed to the environment. And you have the opportunity then to talk to a group of engineers and say, what the hell are you guys doing? Why do you like this? What do you hate about it? What would you change anything? Get into as many internships as you can from the time you're a freshman in college on, if you're in a technical discipline, and there's a bunch of opportunities to do that.
Would you have any advice for somebody who wanted to go specifically into plastics engineering or materials engineering?
Well, yeah, absolutely. By far, one of the most renowned schools is right here in Massachusetts, UMass Lowell. They have a degree in plastics engineering. You can go in right from a bachelor's all the way to a PhD. So it's one of the rare programs. There are other schools. Penn State has a plastics program, and Ferris State in Michigan, they have a plastics program. I would Google those programs. There's others, I'm sure. Those are probably the best known, and the folks I meet in industry, those schools are often well represented at our clients and within our environment.
So you obviously found the discipline that makes you the happiest. Would you advise other people to obviously look at all kinds of disciplines, but is there a clue that clued you in to say, this is the path I really wanted to take, so I did it?
Right. Yeah, it's a great question. I think as individuals, we need to start to internalize a little bit and see, what are our interests? For me, it was, what do I find myself wanting to do on a regular day? I wake up, what do I want to do? Well, I want to build something. I want to do something creative or artistic. So look at what interests you and what brings you energy. So if you're doing something that you're interested in and that you get energy from, you're going to enjoy every day at work. And is it going to be fun? Well, there's a lot of parts of my job that I wouldn't get up and go, I'm going to go, work on my schedule and organize a Gantt chart or something. Everyone has inherent special skills. What's your secret sauce? What are you interested in? And when you're doing it, do you find you have energy, or is it exhausting, right? And pursue that. And that it goes back into the next best step, move forward in that. And so if you're a creative person, you should try and be creative. We're creating value. So whether you're creating it by making beautiful music, beautiful art, or the simplest, best material for a product, or the simplest, best product for use in our world. And there's a job for it out there. It just happens that, creating and solving problems with articles or objects in the world around us is engineering. But there's so many engineering disciplines, and within any one discipline, there's thousands of jobs in the way you can apply what you know. So I would say, take that next step on what interests you, what brings energy, and you're going to enjoy it.
Marc Gagnon, thank you so much for joining us on Occupations. I want to check in with you in 3 years and see how this yogurt cup on the moon is coming. I assume that you're going to work very hard on that project.
You'll be an astronaut at this point as well.
I'm sure I'll be an old man, but that's okay.
The oldest man to go to the moon and eat yogurt. I love it.
Thank you so much for joining us here and
pleasure.
telling your story. We really do appreciate it. Stay tuned for another episode of Occupations coming soon.
Occupations has been brought to you by lotsofmaps.com. Please follow Occupations the podcast on Facebook and Instagram to find information about our next episode or to see what past episodes are available.